Hello and welcome to section 6.2, which is on properties of parallelograms. So a parallelogram is a quadrilateral with both pairs of opposite sides being parallel. So two sets of parallel sides opposite each other. Opposite sides do not share a vertex. They have to be across from each other. Opposite angles cannot share a side. Again, they have to be across from each other. Theorem 6.3 states that if a quadrilateral is a parallelogram, then its opposite sides are congruent. So the sides opposite each other have to be equal. Consecutive angles means the angles of a polygon that share a side, so that basically the two angles on the ends of the side, they're in a row, consecutive. Theorem 6.4, if a quadrilateral is a parallelogram, then its consecutive angles are supplementary. Theorem 6.5, if a quadrilateral is a parallelogram, then its opposite angles are congruent. Just like the opposite sides were congruent, opposite angles are congruent. Theorem 6.6, if a quadrilateral is a parallelogram, then its diagonals bisect each other. So the diagonals going across the figure will bisect each other, cut each other in half, in other words. So using all of those concepts, we are going to solve this problem. All right, so here's the drawing to go with this question. Find the values of x and y in the quadrilateral PQRS, and then I want to know what are PR and SQ, what are the lengths. And so there's quite a bit of work I have to do here, but I do know that if this is a quadrilateral, based on those theorems we just went over, that this side right here has to equal this side, because it says they bisect each other, and this side equals this side, again, because they bisect each other. So if I set this up, I would do 3x minus 7 equals 2x, and then I would have y equals x plus 1. So I have a system of equations, in other words, that I need to solve for this. So because this one is solved for y already, I can take this whole equation, this piece right here, and plug it in for my y. That should be a y, 3y. Plug that in for the y. So 3 times x plus 1 minus 7 equals 2x. Distributive property, 3 times x, 3 times 1. And then I'm just going to continue. So so 3 minus 7. I don't want to do that opposite. 3 minus 7 is minus 4. So 3x minus 4 equals 2x. Then I'm going to move this 3x over to the other side. So minus 3x. So I have a negative 4 equals a negative 1x. I don't want a negative 1 there. Divide by negative 1. My x equals 4. So now that I know my x, I can go ahead and plug that in right here. So 4 plus 1 equals 5. And since this side has to equal this side, and that side just says y, we know that y then equals 5. So x equals 4 and y equals 5. And then I have to use that information to solve for what is P, PR, and SQ. So I need to make some space here. So I'm going to need to erase this so I have some room to work. Okay, so PR, P all the way to R. So 3x minus 7 plus, that's a y, plus 2x equals PR. So I'm going to plug in my answers here. So 3 times the 5 that I just found out that y equals, and then 4 is x, so plug that in. 3 times 5 is 15. 15 minus 7 plus 8. So 15 minus 7 is 8, and 8 plus 8 is 16. So 16 is P all the way to R. So I'm going to erase some of this so that I have room to do the rest. Might as well just erase all of it. I'll just leave that last piece that says x equals 4, and then I'll rewrite in here that y equals 5, which is what we found on one of the first steps. So I still need to find q to s, or s to q, this whole chunk right here. Okay, so x plus 1 plus y is going to equal qs. So plug in your numbers, 4 for x and 5 for y. 4 plus 1 plus 5 is 10, and so SQ equals 10. So we had to use a lot of steps to get that, but it is possible. We started with solving the system, and then once we solved the system, we just plugged the numbers back in to get our final answer. Theorem 6.7 states that if 3 or more parallel lines cut off congruent segments on one transversal, then they cut off congruent segments on every transversal. Okay, so here is the problem to go with this one. So I have if EF equals FG equals GH, and they all equal 6, and A all the way over to D is 15, what is C to D? So C is the point right here, and D is the point right here. They just want to know how big that section is. So how many sections were there? There's 1, 2, 3. And if we read this again, it basically says that they have to be congruent. So if you have a total of 15, you divide it by 3, guess what? Section CD, line segment CD is 5. So then for this last one, given that quadrilateral LENS and quadrilateral NGTH, given that they're quadrilaterals, you want to prove that angle L equals angle. All right, so there's the drawing that goes with this one. So LENS and NGTH are quadrilaterals. I want to prove that angle L is congruent to angle T. So going through the steps here. Bring that down a little bit so you can see the drawing. So LENS and NGTH are quadrilaterals, that is given. Angle L is congruent to angle ENS and angle GNH equals angle T. How do I know that? Because opposite angles of a quad are equal, or congruent. So then I can say that angle ENS is equal to angle GNH. How do I know that? So we're talking about this angle right here and this angle right here. How do I know that? Because they're vertical. So then for my last step, I can say that angle L is congruent to angle T, Y, transitive property of congruence. Here I have proven that L is equal to ENS. So this one equals this one because opposite angles of quadrilaterals are congruent. And then I proved that this one equals this one. Therefore, this one has to equal this one, that transitive property. So bring this knowledge with you, and we'll talk about it more the next time I see you. Have a good night.